So I'm gonna do LeetCode problems today. I'm gonna try to do, I think, between three or four, and spend half an hour on each. And then I think at the end I'm gonna read this stuff here about heap. And I think I'm gonna do this, read the stuff at the end until I got through all of them. I already did the beginnings of it to understand. But some data structures I understand how they work, but I don't really know by the name. And I don't remember the implementation, or I haven't seen the implementation in Python, so I think it's gonna be interesting to read this every time after I do one of these challenges. So I'm gonna start the timer here. Given an array nums of n integers, return an array of all the unique quadruplets. Are distinct. So this is pretty similar to the three-sum problem. I think it's pretty much the same thing, but with 4 numbers instead of 3. May return the answer in any order. So I think I don't remember really well, but I'm gonna try to do the same logic as the solution from the other problem. So I need to return a list with all the sum has to be equal to the target, I think. They're all greater or equal to 0. And they're equal to the target. So I think maybe I can do nums equals list filter of the x. Can I do this? Yeah, I think I can. Oh, but here I have -2 in the output. I don't understand this. Oh, the indexes must be greater than 0, not the numbers. I'm tripping. So for I in range length nums, then I need to create a left and right pointer, if I remember correctly, and then I need to sum the numbers based on that and increase or decrease the left and right pointers until I find the target, and then I increase the left pointer. After finding a target, I increase the left pointer until they are different numbers. Just trying to think if I'm missing something. I never know what names to give this. Maybe rat or and. Oh, right is better. And left and right. Is equal to y plus 1 and left times minus 1. Then I also need to think about the condition. Is either -3 or -4 here. Because I don't want the index to get out of range. Sum nums I plus 1 I plus sure I plus 3. This one also never, I get it confused sometimes if I should increase or decrease. I think the right decreases and the left increases, but yeah, if the sum is greater than the target, that means that the right should decrease probably, because you need a lower number. I think this is correct. And then sum targets left plus equals 1 else left plus equals 1 result dot append I need to put this on a list as well. I think the while has to be, the left plus equals 1 has to be inside the while loop. Or left, right, left plus equals 1. Or if there's also something I'm missing here. I don't remember. Oh, that's the difference, is that on the other ones, instead of using the index here, you're supposed to use the left and right pointers. So it's 3 numbers in total. But now I have to do 4. So I think it's maybe fundamentally different the way you solve it. I think 2 sum and 3 sum is probably the same, because the only difference is that in 2 sum you only have the 2 pointers moving, and then 3 sum you have the one that's at the current index and the 2 other ones moving to find the sums. But if I have 4, how can I do that? Because if I have a fixed one and two moving, then it's obviously 3, and how do I get the extra one? Maybe we can just do it like this. Because here you would be left is equal to unknowns left plus 1. And left, right, then you do this. So this updates the left pointer until the numbers are different. But I don't remember really well. I think might be this might go inside this loop here, the while loop. Yeah, I think I should go inside because maybe not. I was gonna say that the sum is gonna be the same, but I don't think it is necessarily the case that it's gonna be the same. Or maybe it is gonna be the same. Because the right and the index don't change in this while loop here. So if the left is equal to the other one, it means that in the next iteration the sum is gonna be the same. So maybe this line goes inside of this thing here. Yeah, but it has to go outside actually. And then if it's different, yeah, but then this condition here is the problem. And so maybe this way is the right way. This part, for some reason, is the hardest one for me to understand about this algorithm here. And I'm just trying to... At the rest, I think I'm pretty confident that that's the way that it is from the other solutions, from other problems. I also watched the video about this one, the explanation. But this part here, I don't remember really well. And now I have to think about how can I... if this is correct or not. Because I have two numbers here that are not gonna move. That's the problem. And if I create 3 different pointers, let's say one starting from the middle, then I think is maybe it is the right way to do it, but to do it in this way I think is a lot harder. Unique quadruplets. Well, obviously the brute force way I think would be to do for nested for loops and then just get all the sums from that in the end using the 3 different letters, but it's definitely not the best solution. This is probably the right way to do it somehow. You just have to think about how can I incorporate another pointer or another number here. So if imagine that it's a three sum problem, but with one of them fixed. Here you can do a loop. I can do the algorithm for the 3 sum problem and then loop over it. That might be probably not the optimal solution, but better than the brute force one. Yeah, but the issue with that is that I would have to somehow also incorporate the logic of the pointers based on the other one that is moving, because they all have to be unique. And I also realized that I'm pretty much doing the same thing here. This has to be plus true. And maybe I'm confusing here. I think this while loop is probably here. Yeah. Actually, this is probably a lot harder than the previous one, the threesome one. I have no idea how to do this. So maybe instead of the if statement, I put this here. But then I don't remember really well what I'm supposed to do in this condition here. Because it doesn't make sense to be this because I'm already checking in the if statement. So maybe I should just put while sum equals target. And then I think it makes sense for this should be inside of the while loop as well. This control. How do I move lines here? Whatever. Because I want to append these results until if the numbers are equal and I'm moving the left pointer, it means that the other ones are still the same because I didn't change them. So the sum is gonna be the same. But maybe I'm confusing this. Because I remember in the video it talks about the reason why you want to do this is so that you don't repeat numbers. You don't get the same sum for the numbers. Because you don't want to put duplicates on the result. I don't think this is gonna pass, but I'm curious to see the result. What? Memory limit exceeded? I don't even think I'm using that much memory. It's probably the while loops that is incorrect here. Yeah, because I'm not changing the... I'm only changing this sum when I hit the if statement. So this is incorrect. Yeah, I don't remember really well. Kinda wanna look at the solution to the other one so I remember this algorithm here. And still memory limit exceeded. I shouldn't have this. I think that this should be inside of here as well. Or maybe it doesn't matter because I'm using left and right instead of this. Or maybe what I should do is create another for loop inside of this one. And then instead of making I plus 1, I make another letter here. But then I have to change this logic as well. Because they all should be different numbers. I think I should be adding to the list these ones, all the previous ones that I did or I couldn't do. I did, but I didn't know the solution, and I want to remember, and I should probably be going back to them from time to time. There are other ways that I can think about solving this using iterative combinations and products. But yeah, I'm not gonna have time to do that since it's almost over. So I think I'm just gonna look at the solution or the discussion here. Probably gonna have the solution. And I wanted to do this way because I think this is probably the best way to do it. And I assume the logic for doing this is the same as this one, but you somehow include another pointer. And then have to change the conditions so that you are moving two pointers at the same time instead of moving one at each time, depending on the target. And this part here as well, I need to remember both this while condition that I didn't really understand that well. You should probably watch the video as well again. Let me see. Yeah. So I think I'm gonna go on this discussion. Just let me find the video.
Okay, let's solve LeetCode 15, Threesome, the sequel to the popular question.
Speed this up. I'm gonna look at the solution to the other one, then rewatch the solution to this. I'm gonna mark this one. Create new list. What? Do later. Okay, so now I assume it's on this list. I'm gonna put all of this. Yeah, according to the video that I watched, the best strategy is to do that. That's why the reason why I'm doing this way. Which is you do 30 minutes for each one, and then you try to solve it. If you can't, you look at the discussion, and then you leave it up for another time. Then you try to solve it again, and you do this over and over again until you're able to solve it. And if you're not able to solve it, then you just look at the solution, and then you keep doing this until you understand how it works. And I think that's the best approach. I tend to want to solve it, to spend as much time as I can until I solve it, but I think that's a true stubborn way to think about it. It's better to have balance and allow yourself to look at the solution if you can't do it. The risk of doing this approach is that you can become very comfortable. You you stop trying to solve the problem because you know that you're gonna look at the solution later. So that can be a problem. But I think it's fine. Or to solve this problem, you need to do parent problems. Choose some, threesome. A piece of cake. Okay, some problems can be divided into about two problems. Approach intuition. Reduce k sum problem to k minus 1 sum problem. When k equals 2, then it's choose some true problem. But we need to sort the array first. Therefore, we could use recursion to solve this problem. The complexity. BO and times k minus 1. So if k is different than true, for I in range, I don't understand this. Let's leave k plus 1 vowels to set in quad. Another thing that I think I'm gonna do is watch all these videos from this channel. But I wanna wait until I have solved enough of them to make sure that I'm not spoiling myself before I do the challenges. Just setting quants. Avoid duplicates. If I greater than the start probably. And now is equals this. Continue. What's this one? Not this. Already really confusing to me this quad dot append. Where is this? Oh, it's from here. It's calling 4, which is the number of sums, I think. So 4, I think, is the number of pointers or numbers that you wanna sum. Then the start is 0, target is the target. So if it's different than true, so if it's not a true sum problem, it's gonna do this. And then if it is true, it's gonna choose some problem. So this sum is equal to left plus right. So this condition, I think I got it correct there, which is the parent while loop condition. While left is smaller than the right, you keep doing this. If if the target is greater, then you increase the left because the list is sorted in the beginning. So if the sum is lower than the target, it means that you need higher numbers from the left. And the other case, you decrease the right. So I think this part, I got it. So it is outside of the loop, and the left plus 1 is outside of the loop as well, which was another thing that I wasn't sure about. Because I had the feeling that it was, but then got confused. I wasn't really sure. While left. So L minus 1 instead of plus 1. And then it just increases the left here. So I think it was really close to getting. So it is left. The only thing that was weird to me is that it felt redundant to do 2 while loops with the same condition here. But this has the extra ones. So this is the condition that matters, and this is just to make sure that you don't run into an infinite loop. Or, yeah, it don't cross the, not that you don't run into an infinite loop, but the left doesn't cross the right. And this one, so they're calling the function here recursively. So probably the logic is reduce the problem until it's a true sum and then solve it like this. By doing this here. Trying range. So it creates another loop. If I bigger than start and nums I equals to nums I minus 1. I don't understand this comment here. Let's leave k plus 1 vowels to setting quad. What does that mean? Doesn't make sense to me. K sum k minus 1, I plus 1, target minus nums I. So it decreases and then increases the I. Which is the starting point for this loop here. So I think this is pretty much the mechanism of the stack, but I'm not sure. I don't get it. Hopefully there's a video about this one. This part here is confusing to me. I think that the overall logic is you until is greater than 2, the numbers of pointers you wanna figure out for, which in this case is 4, then you run this recursively, which is gonna append the items into this list here. But then it's just returning here. That's what I don't get it. I guess that once it reaches this return is probably relevant. Because it always gonna hit true here at some point. But maybe it's because he did different than true and not greater or equal. That's why. So if you have a number 1, if k is equal to 1, then it's gonna be different than true. And then you need to return. But then it doesn't make sense as well because, well, you're not returning ras. So I think this maybe it is irrelevant. And then the quad pop, I also don't understand. So you're appending the number, you're appending nums I to the quad, and then you're calling again with another pointer I plus 1, and you're reducing the target. So you're changing the sum. Yeah, but then this is gonna call twice, but then why just remove the last number from the quad? So they're pretty much doing the same thing as making nums I and plus nums I plus nums I plus 1 plus left and right pointers. The thing that I did there on mine. But I'm not sure if that is correct because of this quad here. I don't understand how this goes into this one. Oh, here, quad. So it appends the two lists. But why quad pop here? I guess this never is never reached as well. Because you're calling recursively until it reaches true, and then the purpose of this is probably for when the case is when k equals 1. But even that doesn't make sense because it's returning here, so it doesn't. Because it would make sense if you wanted to use it here, I think. when k equals 1. Yeah, but then also doesn't make sense because you're appending more anyway. Hopefully there's videos explaining this. It's very confusing. I think I have to go to the next one. I can't. Oh, actually, I'm gonna search for the name of this guy and the problem. He probably has a video on it. I think I'm not gonna even do this. I'm gonna go to the next one. So I save it for later. Or maybe I should watch this video.
Question 2 sum. So before you solve this question, the first thing you should do is make sure that you've solved 2. On your implementation of sorting, it could be our negative 3 sum to 0, then we're going to add them to the solution set. If this sum, though, is too big, for example, if our sum was greater than 0, we want to decrease our sum. Now, we can do that by taking our right pointer and shifting it. So our right pointer would be shifted here. Notice how that decreases the sum because the numbers are sorted. So if you've solved 2 sum 2 before, you know exactly why this works, and I encourage you to watch that video if you want a deeper explanation. Now, on the other hand, maybe our sum is too small. Our sum is smaller than 0. In that case, we would shift our left pointer. Because the input array is sorted, if we shift our left pointer, we're increasing the sum. Now, there could be duplicates among these left and right values too. For example, if this 1 was a negative 3 instead, right? In that case, we don't want to reuse the same element twice, even among our left and right values, so we would not use the same, we would shift our pointer once more over here. We don't want to reuse the same value for left and right either, so we don't get any duplicates. Now, in terms of time complexity, remember we are sorting the array, which is big O of n log n, and then we are not doing the brute force with triple loops. That would be n cubed. We are using the fact that this input array is sorted to our advantage. We're using one loop to tell us the first value, and we're using the second loop to basically solve 2 sums. So we're going to have 2 nested loops, and that's going to give us O n squared. So that means, obviously, the time complexity reduces to just O of n squared. Now, the space complexity will depend. So for the implementation I'm showing, it could be big O of 1, or it could be big O of n, because sorting actually does take extra memory in some libraries. So it depends on your implementation of sorting. It could be O of n. Okay, now let's get to the code. So we remember we have to return this result as a list of lists. And remember, the first thing you want to do is sort the input array. Next, we want to use each number in the input array as a possible first value. So I will iterate through the index and the value. And remember, we don't want to reuse the same value in the same position twice. So if I is greater than 0, meaning this isn't the first value in the input array, and this value a is equal to nums of I minus 1, that means it's the same value as before. That means we want to continue. We don't want to reuse the same value twice. So we're going to continue to the next iteration of the loop. Next, we're going to use our 2-pointer solution for the remaining portion of the array to basically solve 2 sum. So we'll have left and right pointers. Left will initially be I plus 1. Right will be the end of the list, length minus 1. Left and right can't be equal, so we're going to say left is less than right. Now we're going to actually compute the sum. So we'll say our 3 sum is a plus nums of left plus nums of right. So if the sum is too great, remember, if it's greater than 0, which is what we're looking for, then we need to decrease it, in which case we would say our right pointer needs to be decremented. On the other hand, if it's too small, we need to make the sum bigger. If only I could type today. If it's too small, we need to make it bigger, so shift our left pointer to the right. The last case is if this is equal to 0, so of course we have to add it to our result. So to our result, we're going to append all 3 numbers. So the numbers are a, nums of left, and nums of right. Now, of course, we got to update our pointers, but how do we update it? There's a lot of ways you can do it, but I'm going to show you the way that you can do it with writing the minimal amount of code. So let me just write a comment to show you a little bit. What if we had the 2 sum, basically for these left and right, and we were at -2, -2, so -2, 0, 0, 2, and 2. What if our left
I just realized that the volume is too low.
pointer was here and our right pointer was here? In that case, we found a solution, let's say, right? Then we'd want to update our left pointer, right? So then our left pointer gets to -2 again. But that's the same one as before. So in that case, we want to update it one more time to get it over here, right? Now in that case, now our sum is going to be too big because we're going to be at 0 plus 2. So that's greater than 0. So then our loop is going to execute saying that this is too big, and we're going to shift the right pointer to the left. But notice how that right value is now the same as it previously was too. But that's okay because our sum is going to evaluate as too big, so our right pointer is going to be shifted again. Notice how each value is only going to have one corresponding value that it can sum equal to the target, which is 0. So we only have to update one pointer, and our 2 conditions up here will update the other pointer by itself. We don't even have to worry about it. So in this case, we're only going to shift our left pointer because we don't want to have the same sum. We're going to have to use a loop. So in this case, if nums of left is equal to nums of left minus 1, that means it's the same value, so we have to keep shifting our pointer. But remember, we don't want our left pointer to ever pass the right pointer, so we're going to add that to the condition. So this is all we need to do. Now I believe, unless I've made another stupid bug, we should be able to just return our result and pass the problem with the most optimized solution. Okay, I'm praying that this works on the first try. Let's see. We passed the test case, the first test case. They really want you to buy LeetCode Premium. This is taking... Okay, so it did pass. Usually I have some stupid bugs where I mess up a condition, but okay, so we passed it. This is pretty complicated. I'm not gonna lie, this is a pretty hard problem to solve if you've only just solved 2-sum, so I really recommend solving 2-sum 2 as well before solving this problem. I might have made it look easy with the amount of code I wrote, but don't let it fool you. I really struggled with this problem the first time I was doing it, and you can see here by looking at the evidence a long time ago. Well, 10 months ago, I was pretty bad at this as well. So don't get discouraged. If this was helpful though, please leave.
So I think eventually I'm gonna get it. My understanding of the way that it works now is a lot better than the first time that I saw this. It's not that hard actually, if you think about it. It's more of a question of, because people make it look easier because they have done these problems a bunch of times, so they already know. It's more about not really memorizing the solution, understanding the solution, but the hardest part is the first time, and then the more times you do it, the easier it becomes. So, and that's why I think this strategy actually is actually better than just trying to be stubborn and stay with the problem until you find a solution, because it's a lot faster if you can understand from looking at other people's solutions. And the point is to learn the data structures and algorithms. I don't want to spend too much time doing LeetCode challenges as well. I just want to get the fundamental stuff. Just pretty much know how to implement all the algorithms and understand the data structures and be able to look at a problem and understand what's the best data structure for the problem and the algorithm for the problem. I think that's the main purpose of this. And then outside of that, I think it's pretty much a waste of time, and it's better to create projects. And I'll be right back. Since this one is a really long video, I think I'm gonna watch it off stream. I think I'm gonna do this for all. He probably solved all the problems, or most of them. Also thinking about once I become really good at this, trying to do with C++ as well, to become better with C++. But maybe I won't have time for that because I have to do the other projects that I have. There's two other projects that I want to do. One is this one that I'm mining blocks. Not mining blocks, I'm getting the data from the blocks on Ethereum. I'm not sure if I'm gonna get it from the Polygon decentralized exchange because I was looking into it and it's gonna be a lot harder than I thought because there are no APIs. So you need to find the address from the contracts, and I have to see if there's a way to get the transactions from the address of the decentralized exchanges, and then all of them are very complex, and it looks like it's gonna be too much time. So I think I'm gonna just try to integrate the data from these blocks here with Kafka and Spark, and then display this on the browser. Or I'll think about that because the main priority is just to integrate the Kafka and Spark with the data stuff so I can learn those libraries, and then I have another site that I'm thinking about building, and also I'm thinking about forking the NFT market into another repository and then improving on that as well, so I can use on my portfolio. And also doing Kaggle competition, so it might be a lot of stuff, and not sure how much time I'm gonna have to do LeetCode challenges. Given the head of a linked list, remove the env node from the end of the list and return this head. I don't have any experience with linked lists. I've seen it before, and I think I've seen the implementation, but I don't really remember at all. I'm gonna put a timer here. Given the head of a linked list, remove the env node from the end of the list and return its head. Okay, so the number is from the end until the beginning. So length minus the number. And then you should remove the element from the list. And return the head, which is the first number. No, you just need to return the list. Seems that it might be more tricky than I'm thinking about. So maybe I have to use this list node class here. Because why can't I use just pop? and pop minus n. I don't remember if pop changes the initial list or ragazzo, so. Yeah. So from my understanding, a linked list is a list that each value points to the next one. And then a double linked list is one that each value points to its neighbor back and forth. Linked list, you only pass points for forwards. Forwards. So I guess that's why it's different. So I guess I have to loop over it and stop. But then how do I remove? And I think I'm pretty sure I've seen this before. I just don't remember how to do it. Because I think you need to update all the other pointers once you remove it, and that's why it's harder. Yeah, because in a regular list, the elements don't have any relationship to each other, so you can just remove. But because it's a linked list, you have to. I'm not sure as well what is the method for removing, or if there is a method. Because yeah, I'm probably not gonna be able to solve this one because I don't understand the definitions here in the methods. I'm not sure. This is why something that is confusing to me also is that when people talk about this linked list, and because it seems like it depends on the way that you implement the methods. So even though it's the same logic, people can give different names. I'm not sure if it's a standard thing and each language has already embedded into it, or if it's something that you have to do. It seems to me that it's something that you have to do using the classes. You just create the object of the linked list for each language, which also I don't really understand why that's the case. Why doesn't it come with the language if it's something that is standard and people use it all the time? Why not create just one class and then everyone uses that standard one? So maybe it is that way. So maybe I should research linked list Python. Because I have to understand what methods to use on the list node to see, to think about what kind of logic I can implement. I know that heap, for example, I've learned from Kiki solving the other problem for me. That you have from Python itself the implementation, but I'm not sure about linked lists. And I think at the end of the day, all that binary trees are pretty much lists, and it's just the configuration of the list that matter. But it's also not clear to me when it is implemented through a class and when it's implemented through manipulating lists as well. Python using the queue package. An inbuilt class in Python obviously used for dequeuing, dequeue, but can be implemented in such a way that it works like a linked list under certain conditions. So maybe it's just dot remove the standard. You can also just test as well. It's probably not gonna work. Yeah. Also forgot how to see the methods in Python. I know that string gives me the string representation, but I believe there's some way. Maybe it's just methods. Or maybe I have to use the inspect library. So maybe these are all the methods that I have here. So I'm not sure if I should comment this and add different methods as well. That will feel like kind of cheating if I can modify this. Because then I can just add the index each time that I'm adding a different node and remove based on that index. So I don't like the way that this problem was done from a beginner's standpoint, because it's not that clear. But I guess you should probably read about linked list before solving that one. So maybe what I should do instead of solving these problems is go over the data structures first and study their implementation in Python, so I understand. But then I will probably forget it and have to look. So it's probably better to do both simultaneously, I think. Even though I can probably won't be able to solve the problems, then I can just look at how it works, and it's gonna help me understand better and retain the information. I was gonna put methods here, just there. Yeah. Can also just try to maybe down delete. So maybe the way to solve this is for I in range naive ads. If I equals n. Yeah, but it's still, because I can't remove the item. Maybe I can create a new one. Yeah, we just do continue. And then else I'm gonna add to another linked list. New list nodes. But then what should I put on next? I plus 1, maybe? I'm familiar with shoe pointer, but not for linked lists. I don't understand linked lists very well in Python. I think I understand the theory behind it, which is a list that each element links to the next one on a single linked list, and on a double linked list, each element links back and forth to the next ones, to the neighbors. But I don't understand the methods. I don't understand if if the methods are standard and there is a way that people always do in all the languages, or if every time there's a different implementation, or if in this case here, what methods can I use is just these ones. So, yeah. Right now, what I'm thinking about is I create a new one here, and then I update this one based on the elements of the first one. But whenever I reach the number I should remove, I just skip this number, and that will remove this number, and then I return the new one. But I feel like that's not the way that I'm supposed to do this. So that's why I was searching here. It doesn't seem like it's a very hard problem to solve. It's more a question of understanding what they want. How do you, which node you should remove? How do you know? Note that it asks you to remove the nth node. Counting from the end of the list. So if it says remove second node, they want you to remove, for example. Yeah, that's true. I can just decrease the length of the. I can make a new number equals length of the list minus n. And do the same thing that I'm doing here. But you're right, I have to change the n here. But I'm more concerned with understanding the linked list part of this than solving the challenge, to be honest. But do you think this is the solution to do it? Oh, yeah. So this doesn't work here. Yeah, that makes sense because each element is pointing just to the next one. So the entire list doesn't exist in memory. So you can't loop over it as well. Ah, I got it now. This is why it's more difficult. So let me think. But what exactly are they passing here then? They're passing the last element only. Or the head is the element that is currently pointing at. Which is the one in this case. So what if they pass me a number that is greater than the length of the list? How can I know that? I guess the last element always points to null, right? So that's a way to know it. So maybe I can do n here instead of length. I just loop over. Yeah, but then the problem is I can't figure out the length after that. No, yeah, but not asking this problem specifically, just asking in general. But yeah, you're right. The constraints and all it. But I think one way to know it is that the last element always points to null, if I understand correctly. So even if it wasn't part of the constraints, you can probably figure out through that. Because I'm trying to think about, at least from the way that I'm approaching this, which I'm not sure if this is the best, but I'm thinking about looping until I get to the end and then skipping the number that I'm supposed to remove and adding all the other numbers to this other one. And then I can just return the new one instead. But based on intuition, I think is not the best because you're probably wasting time and memory creating a new one. There's probably a way to remove it without creating a new one. I just don't understand how it works. You can get the length of the list with a while loop. Create a variable which is initially at the head and then do a variable equals variable next. Variable.next. And size plus equals 1 until the variable is none. Then size equals length of the list. Yeah, that's interesting. Do you think is the best approach though? Or is there a better way to think about this? And dot next would give me the next element of the list, right? So I could do, for example, while, oh, actually, because the heads, yeah, not different than, no, then you make variable equals set dot next, counts plus equals 1. I think this is what you're telling me to do. And then you get the length here, then with the length you do the other loop based on this length. And then you skip the other number by adding to this new one. It doesn't feel like it's the best though. I think it probably works. Yeah, I don't see why it wouldn't work, but oh, maybe I have to change the. I have to make this equal to another variable as well. Just realized that. So maybe I should do variable equals 0 and then variable different than null. But then I'm not moving through the linked list as well. So it has to be head and then head on X. So head is one element as well, right? It's not the entire list. And it's the object of, is a list node object. And so variable equals head here. It's probably the same thing, right? Oh, it's none. Okay. Isn't head equals? Like, doesn't make it any difference between, I can also do head here on all three of them. It is the same thing, but this is how it's usually done with an extra variable rather than head, because other problems you might need the head for other things. So, okay. If you do it like this, you lose the pointer to the head and list, since then head becomes on. Yeah, makes sense. But there isn't a better way to do this. Like, can you do it without creating another list, linked list? Is there a standard method to remove the element and update the pointers besides creating a new one? Because creating a new one seems like a waste of resources, I think. Obviously, I would do a count here and then do the stuff that I was thinking about. Should create another linked list, and you aren't doing that right now, anyway. Oh, I was intending to here. Consider list A pointing to B, pointing to C. If you want to remove B, simply set a.next equals C. Oh. Huh. Oh, so I make if count equals n, then I change. I see what you mean. But then it has to be variable.next. No, variable, it's already variable.next. So it has to come before, I think. Before variable, this equality operation here. No, nothing point should be. And the garbage collector will delete it. It's not reachable from anywhere. Do I need to actively call the garbage collector? I think it's GC on Python or something like that. Probably not, right? Because how do I move twice though? Because I only have access to the other one. I obviously can't do .next here. Doesn't make sense, I think. Because this is gonna be equal to the next one each time. It begins with the head, then it is equal to the next. So I have to skip the next when this condition is met. But if I do variable equals variable, it doesn't make sense because I'm just making. I would have to skip one. So maybe I increase the counter. This, yeah. Suppose you are at A in the list I mentioned. Now you can do. Oh, you can do A dot next dot next. So it has to be before this as well, probably. Because I need to check for this condition before. I make this. And the variable equals variable. Yeah, if I can do next dot next, it becomes a lot easier, I think. And then now I just do this. Let's see if this works. So I'm doing something wrong here. Oh, I'm not increasing the count. No, I'm increasing the count both ways. Asking you to remove the nth node in the list from the start, it would be correct, but actually, then from the end. Also, it has to be minus count. Yeah, because it's true. Yeah, but then I don't have the length. Let me think. You aren't actually setting the .next pointer. You mean here? You're just moving with variable. Just confusing to me. Because I think I understand what you're saying, but I just... Because there's no connection between the variable and the variable on the next. I'm just changing the value of the variable, but how do I create that connection? I have to... Maybe I need to... Yeah, but this is supposed to be this node here from this object. I'm also returning heads. I should be returning variable. So this might be the issue. I think you should learn all techniques, should not get stuck for too long. Really try to understand why they work, then try solving problems. Should invent them all from scratch. Yeah, that's a good idea. Yeah, thank you. I obviously don't have any experience doing... I solved some problems on other sites, but LeetCode, I don't have any experience, and also dealing with different data structures and implementing them and solving problems. I know roughly how they work, but I still haven't figured out the best way to retain the information. Because on theory is one thing, but in practice is completely different. So that's the thing that, because my concern is that if I just read this stuff, I was thinking about reading each data structure thing at the end after doing 3 or 4 problems each time. Because the thing about reading this stuff is that I think I'm gonna end up forgetting because it's not practical. Like I think I already understand the theory. It's hard to link it to the practical stuff of how it's done in practice. Delete the cave node from the end should help you here. Yeah, I need to change the condition. But I think, at least if I'm getting this right, this is creating the object, is making this equal to the object, which is a list node. The list node only points to the next element because it only has these methods here. And when I do this, I'm creating different pointers. So it's separate things. And the main fundamental difference is that on the list, in memory, all the values are stored together. On a linked list is like a bunch of different points that are connected through a network, let's say. So the key difference is the memory, I think. And what I'm doing here is I'm creating this chain link through these equal signs. But I don't understand this next on next here. I guess because this is equal to this object, is gonna have all the pointer chain from the beginning element, because each element has a pointer to the next one. So in a way, I am creating a different list node when I do this, because I don't want to lose the information, like you said, from the head. And I'm just skipping one of the connections. And the mistake I'm doing here, but then why am I getting done here? Well, because variable is an object. So that's another thing. I need to return all of the members, I think. So maybe I should store each one in a list as well. No, because this is saying that I should return the same type as this. So I think this is the connection that is still confusing to me, because this shows up as a list here and not as a single object. And I'm also supposed to return a list. Yeah. But from my explanation, do you think it doesn't make sense what I'm saying? Because I think I understand what's going on here, but it's just the confusion about what exactly am I doing? What exactly is this variable here? Is a single number, like a single object, or the entire list? It doesn't make a lot of sense to me, the connection. Here's a nice channel with a lot of... Okay. Yeah, thanks for the help, man.
Hey everyone, welcome back, and let's write some more neat code. Hey everyone,
Oh
welcome
yeah,
back.
I know about this channel. I was watching some of the solutions to other problems from this channel. Yeah, but thanks for the help. I think I'm gonna look at the solution now because the time has passed for this one. But I think I was close here with your help. And then I'm probably gonna look at this and the videos on the other channel. Maybe as well, I should probably... Yeah, I think it might be actually better to pick one problem of data structure at a time. I think maybe I should investigate LeetCode more as well. Because I think you can select problems based on the data structure. So you should pick one problem of each data structure at a time. Try to solve it like this. And then go over the way that it works. It's probably gonna be better. The only issue with doing this is that, and I think this is the hardest part, not for me, but for everyone, is understanding when you should apply something. That's the biggest challenge for me. Because in real problems, you're not gonna know, oh, I'm supposed to use a linked list here, or I'm supposed to use that. But I guess this is gonna come once I really understand how the data structures work. Yeah, but I wish there was something that connected them to real cases, so I can understand why they exist, when it's appropriate to use each one. Find center and middle nodes. Well, fast is not known. Fast equals fast on next. If fast is not known, fast equals fast on next. Return slow. So I guess it's creating two pointers. One points to because it's keeping the slow here. Slow equals node, and fast changes depending on this condition. So it's creating two pointers, one behind each one, and then it's changing both of them while fast is not known. Fast equals fast and next. If fast is not known, oh, so yeah, each one has a value. So I guess here is doing the same thing that I was trying to do there, but this is for finding from left to right. I need to find it from right to left. So previous equals temp, which is equals head. And then it changes temporary to temp.next. And this is just to find the parent. So it's unnecessary in my case, I think. Should think about what index scheme is. So it gets to the point, but this is still not going from the end. That's the thing. Because this is not supposed to go for k amount of times. It's supposed to go from k minus the length of the list. That's why I can use the counter and get the length through the counter. So I should change this condition here, definitely. But the main thing that I still don't understand is this return here. Because here I'm supposed to return a list, and if I do things this way, I think I'm gonna return just the node, the last node. I'm gonna look at the solution and I'm gonna watch the video. It's probably better. I'm spending a bunch of time. But I think I understand now much better than I did before doing this problem. It's not hard, it's just confusing the way that is supposed to work with the types there. That's the main point, I think, of confusion for me. It's understanding the structure of this in the format that is gonna be here. That's what's not. Because in my mind, then what I think they are asking is to return a list of linked nodes, of list nodes. Yeah, it's probably the correct way to do it. So maybe I should have a new here because this, and then I should append the head variable. And then I return new here. And then the only thing that I have to do here is figure out how to make the count equal to the, because the n has to be from the right to the left and not from left to right, I think. So I think I understand how it works, but so it's probably a mistake because of this. Because what if this is no? I also have to think about that. Oh, I should return list node, so I should return just one. One of the elements. Yeah, I'll be right back. But this, it says that I'm supposed to return the list node, but this is returning a list. That's why it's weird. I'll be right back. Yeah, so I think I'll just look at the solution for this one. Maybe this approach is best, actually. I think I'm gonna spend more time. I'm gonna get out of this because I'm just clicking next here to find the problems. I'm gonna spend more time understanding how LeetCode works, the problems, and I think it might be a better approach, at least in the beginning. Should do the thing that I was talking about, which is should do one problem of each data structure at a time, and then spend 30 minutes trying to solve it, then look at the discussion to see the solution, then watch a video about it to see how they do it, and then do this over and over again until I understand how it works. It shouldn't be that difficult. I think the most difficult part is in the beginning, but then once you lock in the way to do it or the way that it works, then hopefully it becomes a lot easier to do it. So this way, they do it on the same way that the other one does it, creating two variables, one for one pointer and two pointers. So one for the current node and the other one for the next one. And they do create another linked list as well. Slow equals dummy node fast firing range n. Fast equals fast on next. So it's getting the next element from end. It is confusing to me because shouldn't it be from the right to left? Well, fast on next is not done. Slow equals slow on next. Fast equals fast on next. I'm also gonna have to pause a lot and just stay quiet thinking because I have to understand how it works. Wow, fast. Maybe I should put some music, actually. Fast on next. And reading these solutions is a lot harder to understand. It's probably better to watch videos. Because I assume for this kind of stuff, that it's easy to find videos and it's better because of the explanation. So maybe I should be... Yeah, but I think reading the solution is also good because it forces myself to think about it. So I should be reading this one solution and then trying roughly to understand how it works, and if I don't, or regardless of if I get it or not, just watch the video of someone solving and explaining the solution. The only thing I don't understand here is why they do this, because it's supposed to be from right to the left. And here they are getting the number from left to right for the next one, which I don't get. Then they have two pointers, one from the beginning and then the other one for the end point. And then they skip the next element through this. Okay. Roughly understand that. I think I'm gonna watch this video now.
Some more LeetCode today.
And probably move on to the next one.
Today, let's solve remove nth node from the end of a list. So we're given a linked list, and all we need to do is remove the nth node from the end of the list and then return the new list. So that's pretty straightforward, right? So in this case, we got 5 nodes. We just want to remove the n equals 2, so meaning the second node from the end of the list, right? So this is the first from the end of the list. This is the second. So we remove this, and then we return this list, which now has 4 elements remaining. So what's the easiest way to solve this? Well, they say from the end of the list. That's inconvenient. If it was from the beginning of the list, it'd be super straightforward, right? N equals 2, remove this node. How can we make that even easier? I mean, what if these pointers were reversed? Can't we just reverse this linked list, start from here, and then remove the second node? And then we're done? That's definitely a possible solution, but it requires reversing the linked list, which we don't actually have to do. And I'm going to show you the easier way to do it. So let's say n equals 2 again. So we want to remove this node. So how can we identify that this is the second node from the end of the list? Like a lot of linked list questions, we can use 2 pointers, but how are we going to make use of our 2 pointers? So what if I had 2 pointers, right? A left pointer and a right pointer. The left pointer.
This concept of 2 pointers seems to be very prevalent as well in all kinds of solutions. It's probably really important to understand really well. Because so far, I think it was used on all the solutions from other problems I saw. So
Pointers at the beginning of the list, and the right pointer is shifted by n equals 2. So our right pointer is going to be shifted.
I'm talking about in pointer terms also helps me understand how C++ works. Because yeah, everything seems to work based off this principle of pointing things to other things. So I think these are fundamental principles. One is memory, the other is the stack. So memory is heap, I think. I don't really... Maybe I'm confusing the two. No, maybe it's not heap, something else. I know there's the name for when you allocate memory to certain variables or things like that. And then you have the stack, and then you have pointers that make the bridge between these things. I think that these are the core fundamental principles to understand, I think.
1, and then it's going to be shifted again.
And then data structures are basically a variation of, or a combination of these fundamental principles.
Pointer is going to be over here. So now we're just going to keep shifting our pointers until this right pointer is at the end of the list. And watch what happens when we do that. So we're just going to be shifting each pointer by 1. And this is going to make sure that the space between these pointers is exactly equal to n, which is 2, right? So now we're going to shift by 1 again, making sure that the gap between them is still 2. Now we're going to shift 1 last time because right is almost at the end. So now our right pointer is at null, right? It's at the end of the list. It can't go any farther. And our left pointer is exactly at the node that we want to delete. And the reason is because, remember, the offset between these two is n, making sure that we have the node we want to delete. Now, there's only one problem. We have access to the node that we want to delete, but we want to delete it. How do we delete it? The only thing we have to do is take this pointer, cross it out, and then reassign it over here, right? Once we've done that, we've gotten rid of this node. So the problem is we're at this node when really we want to be at this node if we want to delete this node. And this can actually be solved by another pretty common technique, the dummy node, right? So we're going to actually have another node that we insert at the beginning of this list that we don't really use. And then
So I understand. You're pretty much creating 2 pointers, and then one goes faster than the other by the amount that you want to delete. Then once the other pointer gets to the end, it means that the other one is at the position that you want to delete, and then you create the dummy one, so that you can make that one the one that changes the list.
Main thing that's going to happen is instead of our left pointer being initialized here, we're actually going to initialize it at the dummy node. So left is really going to be initialized here, and our right pointer, though, is still going to be initialized over here. So in reality, when our right pointer reaches the end of the list, we will have a left pointer at 3, and then we can update its pointer, removing this node that we want to remove. And to return the new linked list, all we have to do is take our dummy pointer and say return dummy.next, which is going to be this node. And since this is a 2-pointer technique, the time complexity is going to be big O of n. So just like in the drawing, the first thing we really want to do is create a dummy node. We don't really care what the value of this node is, but I'll just say 0. But we want to make sure that the next pointer of this node is set to the head of the list because we're inserting it at the beginning. Next, we can initialize our left pointer to dummy, and we want our right pointer to be head plus 2, right? Or head plus n, whatever n.
Yeah, the confusing thing about this is the allocation of these variables here. But I guess I was right there in the beginning, creating this other node here. And then the variable is equal to the dummy, I think. Is that how he did there? And then let's do it just left. Probably easier to understand. Yeah, so the left is equal to the dummy, and the right is equal to the... Yeah, but I guess this part I have to see the video, because I'm not sure how he's gonna make sure that the right is ahead of the dummy by n amount. I guess you can just create a while loop or a for loop, but I'm not sure if that's the way that you're supposed to do. And then you just keep going to the next one until you get there. So let's see.
Gradations are so useful. Happens to be. So we need a loop to do that, right? We can't just do that with a calculation. So we
Yeah.
can initially say right is equal.
So he does the way that I was thinking about. So right equals left dot next. Can I do this like that? It doesn't work. I guess list comprehensions only work if you're doing on a list. But maybe, yeah, let's see. Maybe he doesn't.
And while n is greater than 0 and right is not null, we want to keep shifting right. So shift right by 1 and decrement n by 1. Because once n equals 0, that means we've shifted by the amount that we wanted to shift by.
You can do the same thing that I'm doing here. Well, actually, it's probably right equals right on that. Yeah, right equals right on next. So now let's think about. So I have the dummy, which is the one that is gonna replace. And then the 2 pointers. I mean, it's actually a pretty similar logic to the 3-sum problem, I think. If you think about it. The only difference is that you can only go one way because it's a linked list. And on the other problem, you have the 2 pointers converging towards each other. And this one, you have the 2 ones going to the end of the list. So when this is done, so I guess I don't need the count as well. So I want to move the left to, yeah, and then you should make the dummy also equals to dummy done next. Yeah, but the dummy needs to be one before the. Because if I make dummy equals dummy dot next, then if it's the point, it has to be lagging behind by 1 between the left, but I'm not sure how to do that. Obviously, I can put another variable and then make it equal to 0, and then if it's different than 0, then I increase. And that would make the left be more ahead than the dummy, but I suspect that there's a better way to do this, so I think I'm just gonna look at the solution. But I think I get the point now. So whenever the right is none, it means that the left is the node we want to remove. So Maybe if I put another condition here and I put if right equals to none. Yeah, but when you get to the point, then the dummy becomes dummy.next.next. Just skip the element. It's just this condition that I have to change. So
and the last thing we want to do is keep shifting both of our pointers now. Now we're shifting left and right, and we're going to keep going until right reaches the end of the list. So we can shift our left pointer, and we can shift our right pointer. Now,
I guess this is a better way as well, because if it is none, yeah, it's like the same thing as if it is false, so it doesn't go to the. So the other part is unnecessary.
last but not least, we actually want to delete the node. And remember, all we need to do to delete is update the left node's next pointer. And it's going to basically be shifted by 1. So left.next is going to equal left.next.next. So for example, if my left pointer was at this node, its next pointer is at 2, but I want to set its next pointer to 2's next pointer. So basically what I'm
This, I also forgot to update the right node here.
doing is this. And we know that dummy.next is at the head of our list, which is what we want to return. We want to return the updated list. So we can just return dummy.next. We don't want to include our dummy node in the output. We never wanted to add a node to the list. We just wanted to remove a node. So our solution works beautifully. We could have just reversed the list, but we definitely did not need to do that. I hope this was helpful. Don't forget to like and
I
subscribe.
don't understand this last part here, though. So I guess when you change left, you're also changing the dummy. That's the thing. Because in my mind, the left was supposed to be the value that you don't get there. Because when right equals no, that means the left is the number you want to remove. That's what it doesn't make sense. Maybe that's why it's greater than 0 here. I'm still not sure if I understand this correctly. Equals left dot next dot next. Probably passes. Dummy dot next. Also don't understand why return the dummy from the head. Probably, yeah, left. Oh, so it does return and everything. I guess, yeah. I guess it was like I was talking about. When you change the left value, it also changes the dummy. Because left is just pointing to the dummy. So I guess that's how it works. It stops one before the number before the value you want to delete on this loop. It stops one before, and then it makes the next equals, it skips the value that's supposed to be deleted. But then how does the dummy contain the values that come after that? Because let's say the length of the list is 5 and you stop at 2. Then you would go from 2 to 4, but then you would be missing the 5 value. And not in this case, but if the list is bigger, you're only capturing the last one. I'm still not sure if I completely get it, to be honest. I think I understand the explanation here, the solution, but to understand how it actually works. Because again, the main point of confusion is the output here. The middle next. Oh, is it worth it spending more time on this? Trying to think about good ways to research this so I can understand how it works. Because it's kind of a difficult thing to search for. Maybe I should just do more problems and then I will understand. But the key point for me is understanding the difference between why is returning a list here if this is an object. Because in my mind, what it makes more sense that this should return only one value. Because it's only the list node that I'm returning. And the list node only has access to the value and to the next, to the pointer of the next value. So it doesn't make sense to me. So in this case, the next should be this, all these lists here, maybe? Maybe we should just search for Python
Just going to
linked
remove
list.
those. So our solution works beautifully. We could
Alright,
just reverse the list,
just
but we
subscribe
definitely
on
do
the
not need to
other
do that.
channel.
I hope this was helpful. Don't forget to like and subscribe. It supports the channel a lot, and I'll hopefully see you pretty soon.
The issue with these tutorials is that I know most of them. I'm not gonna talk about the memory stuff. They always talk about the superficial things. At least it's unlikely that they will. Maybe they do, but it's unlikely. That's why I'm thinking about a different way to search for this. Because I'm more interested about the way that it works in the memory and the principles behind the thing instead of just understanding the superficial stuff. I think I already understand the superficial stuff
We will be implementing
of the way that it works. And the reason why this is useful is probably because it's more efficient in memory, because you're not keeping the whole list. You're just keeping one item at a time. So it's probably useful for generators in Python. It is the same principle, actually, I think. Because in generators, you're only getting one value at a time. I think in Python, it's the yield keyword for returning a generator item.
We will be implementing linked list in Python today, and we'll go through various operations on the linked list and the big O complexity. In the end, as usual, we'll have an interesting exercise for you to solve. And here is the list of topics. So if you want to skip ahead to specific topic, feel free. To understand linked list, we first need to look into array because there are some issues with arrays that linked list tries to solve. Here I have an array of stock prices, and this is a memory layout of those stock prices. Basically, there are like 5 elements in this array. If you want to insert an element 284 at location number 1, then it will insert
I think I'll watch this later. So here you can... Interesting. Yeah, so I probably should be searching by these topics here. I think what I'm gonna do is first I'm gonna research which ones of these is more important. Then I'm gonna create a small list of this, and then I'm gonna do problems based on each one. I think I will do this off stream. So what I'm gonna do now is create a list of this, of hierarchy of importance of each problem. Then I'm gonna click on one of these based on the one that is most important. Then I'm gonna try to solve one problem, and then study, then solve, then study, and do this over and over again. So I'll probably be right back. Maybe a couple of hours from now, and then when I come back, I'm probably gonna. And my focus is not gonna be so much on solving the problems, but understanding the principles. And yeah, I think I won't concern myself, especially if I get the general gist of the problem, like I did with this linked list here. I won't be concerned with actually solving the stuff. It's more about understanding the steps and the logic behind them, make sure that I understand the logic behind it, then just passing the thing. So I'll be right back. See you soon.